Geometry section 3.3, one of the simpler sections that we'll do in the whole book. 3 theorems. Notice that they are all if-then statements. So for that reason, what I'm going to do with each one is give you a picture. And again, if-then statements. So what will be the hypothesis will mark in blue, and then what will be the conclusion will mark in red. This should help you to understand what each one of these theorems is saying. Okay, so let's read the first one. By the way, these have no particularly important names outside of this section. They're not really important. It's not like we're going to be citing these in proofs or whatever outside of this section. We are going to do a proof in this section, but outside of this section, this isn't going to get added to the list of important theorems. But they are theorems nonetheless. They deal with parallel and perpendicular. 3.9. So this would be the 9th theorem that we've been given in chapter 3. That's why it's called 3-9. And 3.9 says, if 2 lines are parallel to the same line, they are parallel to each other. So here I have 3 lines. And basically, you have a pair of parallel lines, and then you have another line that's parallel to one of them. Okay? So if blue, this is what is stated in 2 lines are parallel to the same line. This line and this line, those each are parallel to the middle line. Then red, they're parallel to each other. And I'll use 3 arrows there to show that they're parallel to each other. Now, what does that remind you of? It remind you of anything we've talked about and used in proofs? It seems like it's like the transitive property of parallelism, right? If one line's parallel to a second line and the second line is parallel to a third line, well, then the first line is parallel to the third line. That would be an application of the transitive property that is true. Now, the transitive property isn't true for all definitions, but for parallel, it is. All right? So that's one theorem. The next one is called theorem 3-10, and it says in a plane, if 2 lines are perpendicular to the same line, then they are parallel to each other. So again, if blue, we have 2 lines are perpendicular to the same line. So that would look like that. Then red, the lines are parallel to each other, would be like this. And then 3-11, it's interesting, the markings are going to be exactly the same. It's just that the colors are slightly different. If blue, in a plane, if a line is perpendicular to one of 2 parallel lines, then it's also perpendicular to the other. Okay, so we have 2 parallel lines, and one of them is perpendicular to another line. And then we're going to conclude, then it is also perpendicular to the other. So if blue, then red. Take a look at that picture. Again, the markings were the same. It was just that the colors are slightly different. But that's what they each say. Now, we're going to do, I'm going to make one little commentary about a certain section in the homework. It's 14 through 21. And my advice to you is to simply draw it out. Okay? If you just kind of stare at this and not know what to do, you can make it hard. But it's really not. I'm just one of them in particular. I won't even tell you which one it is. It says A is parallel to B, B is parallel to C, C is perpendicular to D, and you're supposed to tell how A and D are related. Well, I mean, if you're just trying to think that through, you're going to have a tough time with it. But just draw a sketch. Okay, A is parallel to B. So here's A and B. They're parallel. B is parallel to C. Okay, well, that'd be another line. I said C is perpendicular to D. Okay, so now they're going to be perpendicular like this, right? I'll even put in the right angle block. Isn't it the case that it's going to be perpendicular with the other ones as well? Because these were parallel, I didn't bother to mark it, but these were parallel. So, and that one was D. So how are A and D related? You got 2 choices. They're either going to be parallel or perpendicular. Obviously, these are perpendicular. That's all they're asking for in 14 through 21. Okay, and then let's do one example. It is a proof, and again, we can do proofs even in this section. So let's see what it says. And by the way, as we've said before, no paragraph proofs. We're doing 2-column proofs only. All right, so notice that these lines are parallel here. There, I thought we were missing something. Okay, sorry. We have a given that A is perpendicular to S. I see that marked right here. C is perpendicular to S. That's marked right here. And A is parallel to B. That's marked already. All right. So when I go to write a proof, statements and reasons, A is perpendicular to S. C is perpendicular to S. A is parallel to B, which is given. And then we can start to think about what we want to do. We want to prove that C is parallel to B. So what do you notice? If you need to pause the video, go ahead. To think about this a little longer, go ahead. Well, first of all, this line right here, that seems like it's just in the way. What's that going to do? I don't think that line means anything. Okay? But don't we have, as I look at this, don't we have a line that's perpendicular to one of two parallel lines? Didn't we deal with that already? Can't we conclude that it's going to be perpendicular to this line as well, right? So we had a theorem that said if a line is perpendicular to one of two parallel lines, it's also perpendicular to the other, and that was the case. So we're going to conclude that. I'm going to conclude that S is perpendicular to B. And look back at the notes if you need to. That was theorem 3-11. Oftentimes here we have abbreviations and such, and VAT for vertical angles theorems, etc. Again, this is not an important theorem after you get done with your 3-3 homework and take the quiz that covers 3-3 to 3-5. So, so we don't need to give it any special name. It's just going to be called theorem 3-11. Okay. Well, now what? Looks to me now like we have two lines here that are perpendicular to a line that's parallel. Sorry, to another line. So wouldn't this then be parallel to this, right? So we can say that C is parallel to B. I'll use a double arrow. Why? Well, because if two lines, how is it said? I got to go back. I don't want to say it wrong. Yeah, theorem 3-10. If two lines are perpendicular to the same line, then they are parallel to each other. Two lines are perpendicular, that's this one and this one, to the same line. That means they're parallel to each other. So that's theorem 3-10. So that was different, right? That's different than the proof writing that we've been doing, but it still follows the same structure, right? And you're not going to make much sense out of that paragraph, so just follow my 2-column proof. Thanks for watching.